Hey everyone, welcome to today's explainer. Right at this very second, there's literally invisible energy bouncing all around you. It's passing through the walls and, yeah, even passing right through you. Today, we're taking the textbook science of those unseen electromagnetic waves and handing the steering wheel straight over to your imagination. We're going to combine your unique creativity with some really solid science to design actual real-world models. We aren't just memorizing facts today, okay? We're learning how to be inventors. So let's get focused and get ready to build something absolutely incredible together. So here's a massive question for you. How can you use the unseen to change the world? Seriously, think about it for a second. Electromagnetic waves are literally everywhere, completely invisible to the human eye, right? Yet they hold this massive, untapped power to solve some of the absolute biggest problems out there. What if you were the one to figure out how to harness that invisible energy and use it to genuinely help someone? Pretty cool to think about. Okay, let's look at our blueprint for today. 1. The unseen power around us. 2. What is a wave model? 3. Why your design matters. 4. How to build your model. 5. Your innovation assignment. And finally, number 6, education, morality, and peace.
All right, diving right into section 1, the unseen power around us.
So science drives real innovation to solve problems and improve lives. Learning about these unseen electromagnetic waves, whether we're talking microwaves, infrared, whatever, it's not just some boring textbook exercise to pass a test. Like, get this fun fact. The entire technology behind the microwave oven, it was actually discovered totally by accident. Yeah, a radar engineer was working with active EM waves and suddenly realized the chocolate bar in his pocket had completely melted. It's wild, right? But that kind of knowledge is the actual foundation for real innovation. By understanding how the unseen works, you're basically gaining a superpower to design solutions that can genuinely improve the lives of the people around you.
Moving right along to section 2, what is a wave model?
Okay, so a wave-based technology model, what exactly is that? Well, it's essentially a blueprint or prototype that uses an electromagnetic wave, like radio or infrared, to perform a real-world function. Basically, modeling an invention means you're moving out of the theory and into the practice. You're directly applying the principles of EM waves to clearly communicate exactly what your design is meant to do. It's like mapping out how a totally invisible wave can become a highly functional, tangible tool that we can actually use.
Which brings us to section 3, why your design matters. Colossians 3:23 reminds us of something super important. It says, whatever you do, work at it with all your heart, as working for the Lord. Now, why does your design matter here? Because, guys, your academic work has a much deeper purpose. When you connect what you're learning to actual innovation, you shouldn't just do it halfway. You really need to do it with all your heart. When you pour your passion into designing a communication system, or maybe a safety sensor or a new medical tool, you're literally using your God-given intellect to truly serve and help other people. And that is huge.
All right, let's get into the nitty-gritty. Section 4, how to build your model.
The blueprint for building your model is actually remarkably straightforward. Step 1, choose an EM wave. Maybe you want to mess around with microwaves, or perhaps ultraviolet. It's up to you. Step 2, decide how it's going to be used. Like, will it heat something up? Will it send a message across vast distances? Then, step 3, create a blueprint or a prototype. This is the fun part where you sketch it out, label all the parts, and explain exactly how the wave's unique properties make your invention function. This step-by-step structured approach, it's exactly how professional engineers tackle massive global problems every single day.
To give you some inspiration, here are 3 real-world examples to spark that creativity. First up, UV waves. Now, they might be famous for giving you a nasty sunburn at the beach, but put them in a portable hand sanitizer box, and those UV LEDs sterilize items and completely destroy bacteria. Pretty neat, right? Second, radio waves. These can be used in a rescue beacon that instantly pings a lost hiker's exact location in an emergency. And third, an EM pulse. Believe it or not, a traffic sensor uses this to quickly detect speeding cars for police alerts. Notice how in every single one of these examples, the specific science of the wave blends seamlessly with a highly functional, life-saving design.
So, it's your turn. Section 5, your innovation assignment.
For this assignment, you need to answer 5 key questions for us. 1. Choose an EM wave and tell me exactly why you chose it. 2. Describe how your design uses that wave's specific properties. 3. What real-world problem does it actually solve? 4. Who specifically benefits from this invention? And 5. Sketch or describe your model in really good detail. I want you to run through these questions and explain your thinking clearly, logically, and passionately. Treat it like you're a professional scientist pitching a groundbreaking new patent. You've got this.
And finally, let's wrap things up with Section 6, Education, Morality, and Peace.
Just like EM waves, your thoughts, your words, and your actions travel unseen, but they create an absolutely massive impact. This right here is our biblical morality tip for today. Think about it for a second. Love, kindness, encouragement, they're entirely invisible, just like a radio wave. Yet when you transmit them, they have the power to completely change the atmosphere of an entire room. So use your creativity, your thoughts, and your actions to build things, whether we're talking physical inventions or personal relationships that help, heal, and uplift the people around you.
Consider this comparison. Education without morality ultimately leads to bad choices that end up hurting others. I mean, really, what is the point of being incredibly smart and highly educated if you're just going to use that intelligence to make decisions that cause pain? It's kind of a waste, right? On the flip side, education with morality, which is the core of the Hero Smart Godly Learner approach, combines your sharp smarts with deep, caring character. And honestly, that is exactly where real positive change happens.
Romans 8:6-7 promises peace of mind to everyone who keeps their mind spiritual. When you align your incredible intelligence with a heart that genuinely just wants to do good, you don't just invent great things, you actually experience a profound sense of peace. And this promised peace of mind is exactly what we continually experience as we engage with this kind of uplifting, character-driven education. So let this sink in for a moment. True peace and real innovation happen when scientific brilliance meets biblical morality. And you know what? You, as 8th graders, are uniquely equipped for this. You have the brilliant minds needed to understand complex stuff like electromagnetic waves, and you have the moral compass to ensure the things you build with those waves will genuinely bless the world. You are absolutely meant to be both brilliant innovators and moral leaders. I want to leave you with this final challenge today. What unseen wave of positive impact will your invention start today? You've got the tools, you've got the science, and you've got the moral foundation. Now it's time to create. I want you to dive into those blueprints, put all your heart into your work, and honestly, I cannot wait to see how you're going to change the world. Thank you so much for joining me for this explainer, and hey, happy inventing!